Hi friends, welcome to a new session on control engineering for undergraduates of 7th semester mechanical engineering. Let's solve problems or numericals on a root locus. It is type 1 problem. It states as follows. Let's read the problem. Sketch the root locus of a unity feedback system having g of s equal to k divided by s, s plus 2, s plus 4, where k is varied from 0 to infinity. Hence, obtain the nature of k for which the system is unstable. Means we have to find the k margin and find the stability zone for this one, and with that find the frequency, that is crossover frequency for this k margin, that is omega margin also need to be found. As we know, there are 9 steps of solving a root locus problem. Let's go through these steps one by one for solving this problem. Solution. As h of s is equal to 1, so because it is a unit feedback system, so we get a generalized equation as below. So the generalized equation will be g of s h of s equal to k divided by s, s plus 2 and s plus 4. Step 1, here we have to equate the denominator term equal to 0. So when we equate this denominator term equal to 0, we get the poles that are the roots of this denominator. The roots of the denominator are the poles of this function for this type of a system. So here we are having, when we equate it to 0, we get one pole, that is s is equal to 0. Another pole, that is s plus 2 equal to 0. Equal to 0. That is equal to s equal to minus 2. Then similarly we are having s plus 4 equal to 0. Answer, s is equal to minus 4. So we are having 3 poles. One is s is equal to 0 at origin, one is s is equal to minus 2 and s is equal to minus 4. So these are the 3 roots of this denominator term. So those are the 3 poles. So in the numerator we don't have any s term, so when we equate it to 0, it will be 0. So number of zeros are 0. So poles are denoted by p and equal to 3. Zeros are denoted as z equal to 0. Next, number of branches. So number of branches is equal to n. Out of this one, whichever is highest, that is going to be the number of branches. So n is equal to p here, obviously, because p is equal to 3. Hence here we get number of branches is equal to 3. Next, we have to find out of these branches, which are the branches, number of branches which are ending to infinity. So to find the branches to ending to infinity, we have p minus z is equal to 0. So p is equal to 3. 3 minus z, that is 0, equal to 3. So we get here 3. So the 3 branches are going to tend to infinity. So this is step 1. Next, we are having to find out how many are going to proceed to infinity. Thus, as I have told, 3 root loci out of the 3 branches all will be proceeding to infinity. Next, step 2. We have to draw the poles and zeros to a suitable scales. Here there are no zeros, so we'll draw it. How to draw? So we draw like this. So small to a scale we draw. First we draw a vertical line. So like this, right here plus j and minus j, and then we draw a horizontal line which is going to be passing through the center. Then here plus sigma and minus sigma we write. Here at the point at origin we are going to mark the poles cross mark, and this one is s is equal to 0. So we get the first pole s1 equal to 0. Next, at a small distance we are going to scale the distance. We get here another point, that is s is equal to minus 2. So s is equal to minus 2. So this is negative axis, so it is going to be minus 2. Similarly, at a equal distance of this one, we get another pole which is going to be marked here, that is equal to s is equal to minus 4. Okay, this much you have to mark. So this is drawing the poles and zeros. As there are no zeros, no need to mark the zeros. Next, important one, finding or testing the real axis loci. So how to find it? So we are going to move from the origin on the negative real axis line. So this is origin. From here we are going to move on the negative real axis line. So this is real axis line. So this side it is positive, this side it is negative. Here this one is an imaginary axis line. So we are moving from the origin to the negative real axis line, and moreover root locus or RL is present whenever the total number of poles and zeros on the right hand side is odd. How to check this one? So first we have to check it whether the root locus is present or not. So what you do, test between 0 and minus 2. Between these 2 points you stand and count how many poles are there on the right hand side of the diagram. So we can see that it is there, it is count is 1. So as the count is 1, so it is going to be odd, and hence the line which is present between minus 2 and 0 is going to be a root locus line. So this is RL, make it thick. So this is root locus line. Then here when we are going to stand here and check how many number of poles and zeros are here, there are none. So here that will be 0. 0 means it is even number. So this is also a non-root locus line. This is a non-root locus line. Okay, so 0 to plus infinity is a non-root locus line. Next, second check. Second we are going to check from this minus 2 and minus 4. Here we are going to stand in between these two poles. We are going to stand and count how many poles, total number of poles and zeros are there. So 1 and 2, that is an even number. Hence when it is even, so the testing line between minus 2 and minus 4 will be a non-root locus line. So this is a non-root locus line. So need not darken it. Next we stand here between minus 4 and minus infinity, or here this side we stand and count total number of poles and zeros on the right side, that is 1, 2 and 3. A 3 is a odd number, so the line from s minus 4 and minus infinity will be a root locus line. So root locus line is present between minus 4 and infinity. So we'll dark it and we'll write it as R. And one more thing what we have to identify here is when there are two poles on a real axis, and when these two poles, between these two poles of the real axis, if it is a root locus line, then there is a chances of one breakaway point happening here. So here we will be getting a breakaway point. Okay, let's check whether it is going to come or not. Okay. Next, step 4 is to determine the number of asymptotes. To find number of asymptotes, we have a formula p minus z is equal to. So p is equal to 3 and z is equal to 0. So number of asymptotes is equal to 3. Next, using this one, we need to find out angle of asymptotes. So angle of asymptote can be determined by a empirical formula, that is phi asymptote phi a equal to plus or minus 180 degree bracket 2q plus 1 by p minus z. Now under this one we know p minus z is equal to 3. Next we need to find out what is to be substituted q. So here q is equal to p minus z minus 1. So p is equal to 3, z is equal to 0, minus 1 remains there, 3 minus 1 will be equal to 2. So q is equal to 2, but not directly q we are going to substitute 2. So for values of q which will be starting from 0 to 2 is going to be checked. So q is equal to 0, 1, 2. So we are going to have 3 iterations or 3 angles, that is at first one at q equal to 0, second q equal to 1, third at q equal to 2. So let's find out for q equal to 0. So at q equal to 0 we are going to find the first asymptote angle, that is phi a1 equal to plus or minus 180 degree bracket 2 into where q was there we substituted 0 plus 1 divided by 3. So we got here 3 get here we got here 180 into 1 divided by 3, that is plus or minus 60 degree. Similarly, when we substitute q equal to 1, we get asymptote angle A2, that is plus or minus 180 degree, 2 into 1 by plus 1 by 3 equal to plus 180 degree. Then similarly, when we substitute q equal to 2, we get the asymptote angle A phi A3 equal to plus or minus 180 degree, 2 into 2 plus 1 divided by 3 equal to plus or minus 300 degree. So here we are going to get 3 angles, that is plus 60 degree, plus 180 degree and plus 300 degree. To draw these angles we require to find out the centroid. So next one is to find the centroid. Step 5. To find centroid we are having a formula sigma c is equal to, means it is going to lie on the real axis line sigma. Sigma c is equal to summation of the poles minus summation of 0 divided by p minus z, means real part of pole minus real part of zeros divided by p minus z. So we are going to take the parts here. So we know sigma c is equal to 0, minus 2, minus 4, minus of minus 0. So from where we got this one? We got it from our first part, from where we had s is equal to first one, if you remember, s is equal to 0, s is equal to minus 2 and s is equal to minus 4. From there we got this one, and we don't have any zeros, so 0 of this one 0, minus 2 and minus 4 minus of 0, p minus z already we know how to get it. P is equal to 3, z is equal to 0. So minus 2 minus 4 minus 6 divided by 3 we will be getting sigma c equal to 60 degree. Next, using this centroid we have to find out the centroid and find the asymptote angle. So we know here in the previous diagram only we can do this one. I am re-preparing the diagram here because I can't go there. So here itself only preparing. So we know this one is s is equal to 0. This one s is equal to minus 2 and this one this one s is equal to minus 4. So here we got centroid equal to minus 2. Here itself only we got centroid. So here from the centroid, what we are going to draw? We are going to keep the sigma here. Keep the protractor here. The D of the protractor keep here. Measure 60 degree from this side. So we'll be getting an angle like this. So this one angle will be phi A1. Then measure from this one 180 degree. This one will be phi A2. And from this side itself only measure 300 degree. Draw a line like this. It will pass through the intersection line of a imaginary axis, and this one will be phi A3. So neatly you draw, you will get it. So using this centroid, you are going to make a use of the angle. So in the graph sheet when you are drawing, there I will explain you still in detail. Next, as we are shown that centroid has been done, and then we had found out the asymptote angle AS1, AS2 and AS3. We need to find the breakaway point. As I mentioned that the breakaway point is going to lie between on the root locus line between these two poles, s is equal to 0 and s is equal to minus 2. What is that point that we are going to find out? So here for finding out the breakaway point, we use the characteristic equation, that is denominator plus k into numerator equal to 0. Here we get or 1 plus g of s h of s is equal to 0. So we are being given the standard form of the generalized equation, that is g of s h of s, that is k divided by s, s plus 2, s plus 4 equal to 0 and plus 1. When we take LCM of this one, this will be s, s plus 2, s plus 4 plus k, and this one will multiply with 0. So we get s, s plus 2, s plus 4 plus k equal to 0. Then multiply these two both, a plus b form. So you get s squared plus 6s plus 8. Then multiply this s inside this one, you get s cube plus 6x squared plus 8s plus k equal to 0. Now keep the k here itself only and write on the other side. This should be in the form of k should be equal to a function of s, here. Okay, so what will happen? We want it in this man. So what we do, keep k this side, take all the other terms on that side. It will be minus of s cube plus 6x squared plus 8s. Then differentiate k with respect to s, then equate it to 0. Here we have to differentiate k with respect to s, and then later we have to equate it to 0. So when we differentiate this above equation, we get 3s square plus 12s plus 8 and equate it to 0. Next, solving this above equation, this is a quadratic equation. Solve the above equation. We get the roots, two roots we are going to get. One is minus 2 plus j of 1.54. Do it in a calculator, you will get this one. Another one is minus 2 minus j of 1.54. These are the two roots for this above equation, for this equation. Okay. Next, therefore, to find out the breakaway point, we get here minus 2 plus 1.54, that is minus 0.85. Then one more point we are going to get minus 2 minus of 1.54. So we get minus 3.14. So we know that minus 0.85 will be lying here, because this is 0, this is minus 2, means it will be lying here in between. So this here we will be getting minus 0.85. So this is lying on a root locus line. What about minus 3.154? So this will be, this is 2 means this is 4, means obviously it is going to lie somewhere here. I am taking roughly, so it will be lying here in between this zone, that is minus 3.154. Means from visualization, from seeing through this problem, we can get to know that out of these two breakaway point, one point is going to lie on a root locus line, another point is going to lie on a non-root locus line or NRL. So the point which is going to lie on the real axis loci or a root locus line is going to be called as a valid breakaway point. So the valid breakaway point here is S is equal to minus 0.85. Okay, means one branch is going to come here and another branch is going to come here. The breakaway is going to happen, and after breaking away, the branch is going to move in the top, that is plus 90 degree, minus 90 degree. Okay. Next, after finding a breakaway point, next step is to find the angle of departure and angle of arrival. As under this problem, we are not finding the angle of departure and angle of arrival, not needed, because we don't have any complex poles, neither we are having any complex zero. Hence, this is not needed. Okay. Next, step 8. Here we need to find out the crossover frequency or intersection with the negative real axis. As I have told you, in a plane we are having, in a S plane we are having two parts, that is a real axis line and one more is the imaginary line. So imaginary line. So the intersection with the negative real axis, this one we are going to find with the imaginary line, where it is going to intersect with this one, that we are going to find out. So the characteristic equation is d plus k into n equal to 0. It is obviously, we know that s plus 2, s plus 4 plus k equal to 0. While solving the breakaway point, there we had this one. So we get from here itself only. We get. Okay, from here itself only we get. So s cube plus 6s square plus 8x plus k. So we have to find out this first k value. For that, what we do, we apply the RH array. RH array we know obviously how to do it. So we apply the RH array. Here we are having s cube coefficient, that is 1. Then s coefficient is 8. We fill here 1 and 8. Next, direct coefficients of s square, that is 6. And next k we are going to fill. So to fill s1, multiply 6 into 8 and minus 1 into k divided by 6. So we'll be getting 48 minus k divided by 6. Next term is not there, leave it. Then come to s0 to be filled, multiply 48 minus k with k and 6 multiplied with this one divided by 48 minus k divided by 6. So it get cancels, only remains k. As we got these elements, that is the first column, this column we have to check, totally. So out of this column, which are the elements which are having the k term? So for stability, column 1 should be always positive. So we have checked that one. There should not be any sign changes to check the stability. And when all the elements are to be positive, means the maximum value of k can be obtained by equating all the elements of the k either to equal to 0 or greater than 0. So hence what we do is, here first we take k one value, it is greater than 0. Okay, that we got. Next, one more term what we are having, 48 minus k divided by 6, this term we are having, that also we can equate it to 0 or a greater than 0. Here we will equate it to 0. 48 minus k divided by 6 equal to 0. So here 6 multiplies with 0, 0. 48 minus k equal to 0. Then minus k equal to minus 48. Then hence k value will be equal to 48. K value will be equal to 48. Therefore, the k margin or a stability margin is 48. So for any values between k equal to 0 to 48, it will be stable. For value of the gain, that is the k gain, is more than 48, then the system becomes unstable. Next, after finding the k margin, we need to find out the omega margin. So it is the continuation part of this one. That is for finding the JW. JW means J omega. We have the auxiliary equation in the S second row. S second row where we had? Here we had S second row. This one S second row or S to the power 2 row. 6 into S square plus K. So this one we are going to use. So we got 6x square plus K equal to 0. So here whatever K value we got, we are going to substitute, that is 48. So 6x square plus 48 equal to 0. Then 6x square is equal to minus 48. So S square is equal to minus 48 by 6 equal to minus 8. Hence S is equal to root of minus 8. So we get plus or minus J 2.8. So when we compare this one with the omega, so JW, we can compare this one, we compare with the plus or minus J omega. So this omega equal to 2.8 radians per second. Therefore, this is the frequency margin or a frequency range for a stability. So after step 9, step 8, we are going to go for the step 9 for plotting the graph. So this is how we are going to plot the graph. First, take the scale. Take a scale 1 centimeter is equal to 0.5 units. So here we know that the plot is going to come on the left half of the S-plane. Hence, don't take much of the points on the right hand side. We know we have to go on the left half of the S-plane. So first draw a thin line on the x-axis like this. Okay, and mark it. And draw a similar thin line on the y-axis. Here, mark it. Here also draw same one. And x-axis minus here this side you draw. And grid, as I have told you, 0.5 units, 1 centimeter is equal to 0.5 units. So here one grid will be equal to 0.5. So this is 0, this is 1, this is 1.5, this is 2. These are all plus. Similarly, on the, because root locus are symmetric about real axis, so whenever you are taking the grid point, take it for y also same. So here it is my plus j of 0.5, here the j of 1, j of 1.5, j of 2.2, j of 2.5, j of 3, j of j4, like this. Here take on the negative side minus j1, minus j2, minus j3, minus j4. So put an arrow mark here. Then write here plus jw if you want. Okay, here. Next, after that, identify the poles. So how to identify? Here we are going to identify the poles. So this is first pole. Mark it at S is equal to 0. And here you write S is equal to 0. Okay, and at this particular point the branch is going to start. Write k equal to 0 there. Then next point, we are having here negative parts, that is minus 1, minus 2, minus 3 and minus 4 and minus 5, and this is going on like this on the infinity side. Next we want the next pole, that is S is equal to minus 2, so it will be coming here S is equal to minus 2. We'll put it here and we write here S is equal to minus 2. Similarly, we are having another pole, that is here S is equal to minus 4. We write here S is equal to minus 4. So we know at poles the branches are going to start. So they are the starting point of the poles. At that particular point k will be also 0, k will be 0, here k will be 0. Then between the two poles, which are the root locus line which we have highlighted, that we are going to bring it here. We know between S is equal to 0 and S is equal to minus 2 there is a root locus line, so we'll highlight this one. and between s is equal to minus 4 and infinity we add another root locus line. This one we are going to highlight. So here we will write RL. Here also we are going to write RL. Okay. Next we are having the centroid. So what we do here, we are going to take the centroid, keep the protractor here at centroid, that is 0.2, it is sigma minus 2, this is sigma plus means this is sigma minus 2. No doubt it will be coming on one of our pole, that is s is equal to minus 2, no issues. Keep the protractor here like this, D you keep, okay, and measure 60 degree from this side, that is anti-clockwise direction. Put a mark here, okay. Draw a thin line, thin dotted line, which is going to go through the I imaginary axis. It is going through this one, and it is called as the asymptote angle 1. So it is called as a AS1. Okay. Then again measure 180 degree this side. It is going to be on the same line of the negative real axis. So here you write it as AS2, that is 180 degree. Then keep the protractor down here, okay. From this one we know that straight line is 270 degree plus 30 degree you add, so you'll get 300 degree. So you'll get the 300 degree line. So draw this 300 degree line. So draw a dotted line and tell that one it is asymptote angle 3. So these are the angles. Next, after finishing all this one, so what we need to do here, we have to find out the breakaway point. As we have found the breakaway point, the breakaway point was, if I remember, it was minus 0.8 something, 0.8. So let me see what was the breakaway point. Minus 0.85. 0.85. So identify the point where it is. So here it is 0, this is 1 means, so here we are going to have the minus 0.85. This is a breakaway point, and at the breakaway point we are going to get the here angle to be departed. So it will be minus 180 degree divided by number of poles between these two, that is equal to minus 90 degree. So here draw one small angle 90 degree, here angle 90 degree you draw. Then what you have to do, you have to find out the crossover frequency or the intersection point. So the intersection point here is J plus 2.82. J 2.82, where you got here 2.8 we have got here. So from there, so this is J1, J2, this is J3, and here we are going to get J 2.8. So identify this point. And next, it is symmetrical about the real axis, so we will be getting minus J 2.8. Okay, at this particular point, what is the value of K? K margin is equal to 48. Okay, right here K margin equal to 48. Here also write K margin equal to 48. These are the things you have to write. Okay, now there are 3 branches. So one branch, it is going to start at s is equal to minus 4 and it is tending towards infinity. So this is one branch. One branch may start from s is equal to 0 and another branch will start at s is equal to minus 2. So these 2 branches are going to break away. One will be tending towards the top, this part. So it will be going a freehand sketch you draw, and it will be moving towards the direction in which the asymptote line is going to move. So it is going like this, and it should go pass through this intersection point, that is imaginary axis intersection point, and then it will go parallel to the asymptote line. Where it is going? It will be going till k tends to infinity. Show this one, k tends to infinity. Similarly, draw on the other side symmetrical. So it will be going like this, and it passes through j equal to 2.828 or 8, and then it is going to go parallel to this asymptote. Parallel to this one it will go. So it will be tending towards infinity. K tends to infinity. Means here the k value is going to go from 0, 1 to some value. Here at s is equal to -8, if you substitute whatever k value get at this particular point, it is going to break, and for all positive values it will be remaining stable. Means on the left half of S plane, this side it is stable zone. This is stable zone. Stable zone. And right half, after crossing this K margin or marginal stability line, so it will be in a unstable zone. So I have written here stable, unstable. So for stability to remain in the given problem, what we should have? We should have the system lesser than k value. Okay, this completes your first problem. For any details or for any queries, please do contact me at naveen.kalal@canaraengineering.in. Thank you.